Hi, I'm Owusu and this is Chemistry Goes to the Movies. My presentation is about the superdrug in 21 Jump Street and the feasibility of creating a drug that has 5 very different effects.
Is this funny to you guys?
Phase 1 is the gigs, or euphoria. Nitrous oxide, also known as dinitrogen monoxide or laughing gas, is a relatively safe, small molecule that stimulates the mesolimbic system and causes a release of dopamine. It generates a euphoric effect by restricting oxygen, however this can be a negative as it can lead to unconsciousness or fatality. THC, which is the active ingredient in sativa, a strain of cannabis, works by blocking anandamide receptors, preventing its breakdown and thus causing a high.
I mean, if I wasn't the coach, I'd be laughing my ass off at how spastic they are, but I am the coach, so I need you. I need me some Doug McQuaid. Understand?
Tripping is the second phase. Lysergic acid diethylamide, also known as LSD, causes intense hallucinations by binding to serotonin receptors. Magic mushrooms, also known as psilocybin mushrooms, work by psilocybin being metabolized by the liver into psilocin, which causes extremely intense hallucinogenic effects. Tryptophan is the amino acid with a full indole amine ring, and many molecules shown below are derivatives of tryptophan, including psilocybin and serotonin.
One particle of unobtainium has a nuclear reaction with a flux capacitor, carrying the two, changing its atomic isotoner into a radioactive spider. Fuck you, science!
Alcohol, and more specifically ethanol, is a depressant that can increase confidence. It works by lowering the activity of the prefrontal cortex that affects decision making and inhibiting the central nervous system. The way it actually works in the brain is its solubility with water due to its OH group that can form hydrogen bonds. It dehydrates the brain, thus slowing down chemical processes. Anti-anxieties can also temporarily cause an increase in confidence.
No, keep it going! What are you doing? What are you doing, nigga? What? Recline! Don't throw the baton!
The penultimate phase is the energetic phase that can be caused by stimulants that enhance CNS activity. 3,4-methylene dioxy N-methylamphetamine, known as MDMA, is the active ingredient in a common drug called ecstasy, given its name due to its ecstatic effects. Cocaine is a tropane alkaloid with central nervous system stimulating effects and also works as a local anesthetic. Cocaine binds to receptors and transport proteins and inhibits the reuptake of dopamine, serotonin, and norepinephrine into presynaptic neurons. The final phase is sleepiness. Sleepiness is mainly caused by depressants such as ketamine. Ketamine is a general anesthetic used for medicinal and veterinary purposes, as well as recreationally. It reacts with hydrochloric acid and is metabolized by the liver. Benzodiazepines are another type of depressant. Their active site is a phenyl group. An example of a BZ is Valium, which is also known as diazepam. Prozac contains an amino group and works by stimulating the activity of serotonin. So finally, could this drug actually be made? Well, there are already mixtures of drugs on the market. For example, a speedball is a mixture of cocaine and heroin. These two drugs have extremely different effects, and the combination can cause highs and lows or totally new sensations. To create this drug with multiple mixtures and multiple compounds, a vector such as a bomb or a capsule would have to be used. Most of these drugs won't react with each other as they only react when in solution. N2O, nitrogen monoxide, would not be able to be used as it's a gas, so it couldn't really be included. However, you could avoid this problem by using THC, which has similar euphoric effects. The order of phases, however, would also be hard to predict. It'd be based on the time it takes for each compound to be metabolized. Finally, if you wanted to create one molecule that could do all these things, they'd have to have the active site of all the molecules I've shown in this slide. This might make the molecule too big and thus unable to fit to the relevant binding sites. Thank you very much. This is the end of my presentation.